Hello, so today I'll talk about chapter 14.2. It's now we started to learn about the actual partial derivative, not concept wise, and it's more like equation wise. So, concept of partial derivative is still the same. When it's fx, then only x moves and y is just constant, and when it's fy, x is constant and y is the only variable, and we just differentiate as we think the other variable as constant. So for example, here question 27 is asking us to get zx, so that means y is constant. So all the y's here in this equation we will think as just constant, like just 4 or 5, any of that. So when we differentiate the z to zx, first derivative side whole thing will equal cosine the whole thing, and then we have to use chain rule, so you have to differentiate the inside part, which will drop 3 to the front, so it will be 15x squared, but we don't use product rule because y, it looks like variable but actually we are counting as a constant, so we just leave it like the 5. So only variable x got differentiated. Same here, same for the 3xy squared. Y squared is constant, so we'll just leave y squared. We only differentiate x, which will be 1, so we'll stay like this. So this is zx, so this is the derivative of function z when y is fixed as a constant number and only x is moving and changing. So let's do another practice. For 28, we have to get gx again. So again, y is constant, y is fixed, only x is moving. So this time the equation is ln y e to the x and y. So simple. First we have to differentiate, but this time also we have to leave y and y here as a constant. So first, ln, derivative of ln whole thing will equal 1 over whole thing inside, and then we use chain rule again, so times the derivative inside. Usually we would have done product rule because it looks like there's 2 variable, but actually because y is constant, again is fixed, we don't think y as a variable, so we'll just leave y and then do the derivative of e to the xy. But e to the xy, the derivative of e to the xy is same, e to the xy, and then we have to do another chain rule for the power of e, which is x and y, and derivative of x and y is just y because y is constant, so we can see this as 3x. For example, 3 is y. If we differentiate this, it will just be 3. So same in this case, the derivative of the power of e will be just y. So it will end up as this, and these cancel out, so we'll just leave it y. Thank you.